Hello students, in this video I'm going to show you some of the factoring techniques. We have a total of about 7 or 8 of them, but I'll show it to you in 2 different videos. So this is part 1. First thing we're going to learn how to factor is the trinomial x squared plus bx plus c. Notice here a equals 1. So if you have a trinomial where the leading coefficient is 1, this is how you factor it out. If we multiply two binomials to get this trinomial here in example 1, we need to have an x times an x to get an x to the second here. And we need to think about two numbers that multiply to 20 and add up to negative 12. Negative 10 times negative 2 makes positive 20, and negative 10 and negative 2 makes negative 12. So this will be the correct factorization for x squared minus 12x plus 20. So whenever you see a trinomial that looks like this, all you have to do is think about two numbers that multiply to c, and at the same time they have to add up to the b. So think about two numbers that multiply to negative 16 and add up to negative 6. Of course, we need an x and an x. Negative 8 and positive 2 multiply to negative 16 and add up to negative 6. So it's how you factor trinomials with leading coefficient of 1. Please pause the video and take these notes on a piece of paper. The second type of factoring is when we have actually a trinomial, but this time a is not equal to 1. The way we factor this out, there's many ways. Some teachers actually teach it to you in where you do a little x and you figure out the factors, and I'm going to show it to you in a different way where it always works. You multiply the first and the last number and you write it like this. And then you factor it out the way we did the first two examples, because here a is now 1. And so we think about two numbers that multiply to 30 and add up to negative 7. So we need an x and an x for sure. Negative 10 and positive 3 multiply to negative 30 and add up to negative 7. But remember, we multiply something by 2, so we need to somehow reverse that and get back to our, because this is not the answer. You know, this here, it doesn't multiply to 15. 3 and 10 doesn't multiply to 15. And so to do reverse that process, we need to divide something by 2. Because we multiply by 2 here, now we need to divide something by 2. The only thing that is divisible by 2 is 10 here. So this is a rule, and it just works all the time. If you divide this set of parentheses, the left one, by 2, you need to put that 2 on the other set of parentheses, but next to the x, like this. It always works. It'll be hard to explain why it always works, but it always works. And so the answer is simply x minus 5, because 10 divided by 2 is negative 5, and then 2x plus 3. Remember to check the factorization is correctly. What you could do is you could do distributive property, combine like terms, and if you get your original trinomial, that means you did it right. So go ahead and pause this video and check that it actually does work. Okay, example number 2 for this type of factoring is this one right here. So remember, when the leading coefficient is 1, it's not 1, you multiply the first and the last number okay. Now we need to think about two numbers that multiply to 24, negative 24, and add up to 2. So I'm going to write x plus 4 and x minus 6. That almost works, except the signs are flipped, because negative 6 plus 2 is going to give us 2. Negative 2, we need a positive 2. So we need positive 6 and negative 4. Now, because we multiply again, look, we multiply by 3. Now we need to divide something by 3. What is divisible by 3? 6 is. So when I divide this number by 6, I have to put that 3 on the other parentheses next to the other x. So here's the answer. The answer is 3x minus 4 parentheses x plus 2. Again, You could distribute and check that it actually works, but it does. If you need more examples, you could always search up more videos on how to find the factorization for a trinomial where the leading coefficient is not 1. But let's move on. If you look at this next one, the third type of factoring that we do, we call it the difference of two squares, and so whenever you see the difference of two squares, you're gonna factor it as a plus b times a minus b. Now, it would be helpful if we know what perfect square numbers are, because when we start recognizing them, it's easier. Perfect square numbers are numbers that when you multiply a number by itself, you get that number. So, for example, 1, because 1 times 1 is 1, 4, 2 times 2 is 4, 9, 16, 25, 36, 49, 64, 81, and 100, and blah, blah, blah. Just the list keeps going forever. So it's important that we recognize those perfect square numbers, because when you see something like example number 5 here, you see that 4 and 9 are perfect squares. So that means I could always write this as 2x in parentheses squared minus 3 squared. And the only reason why we would do that is so we could match a is 2x and b here in this formula is 3. So when we need to factor this out using a plus b, that means 2x plus 3, and then a minus b, meaning 2x minus 3, and this here is a factorization. So we just use that simple formula. Look at the next one. 64 and 121 are also perfect square. The next number right here would actually be 121. And so they're both squares, and we have the difference of two squares. So all we have to do is recognize that 64 is 8x squared. 64x squared is 8x squared. And 121 is 11 squared. So here's my a. A is 8x, and then b is 11. So when I substitute those numbers into this formula here, I get that 8x plus 11 parentheses 8x minus 11 is the factorization of this binomial. Let's move into the fourth type of factoring. This one actually requires some memorization, so you have to memorize the sum and difference of cubes formula for factoring. And please notice that I'm going to write the same formula and in this formula, notice how the sign in the first parenthesis follows the original sign. So there's a plus here, we put a plus here. This is a minus, we put a minus here. Okay, first of all, we have that. And then second, notice that only two signs change in both formulas. This is a negative, this is a positive. And then the last one is always positive in both formulas. So if you could memorize that, those two formulas, you should be able to factor out the sum and difference of cubes. Now, just like we did before, it would be nice if we could recognize some perfect cubes. Please start recognizing 1 times 1 times 1 makes 1. 2 times 2 times 2 makes 8. 3 cubed makes 27. The next one would be 64. 125. 2 16. 3 43. And so on. I don't know too many of them, but you can figure it out with the calculator. The next one would be 8 times 8 times 8, 9 times 9 times 9. I think that one is 712. Anyway, so please recognize the first one here. We have x cubed minus 27, but 27 happens to be a perfect cube. It's 3 cubed. So we could write this as x cubed minus 3 cubed. That way we could match with one of these formulas here, a and b. X is my a, b is 3. B is 3. So now substituting this a and b into this formula, we should be able to finish the factorization of this problem. So it is a small parenthesis and a bigger one. Notice the formula is a minus b. so x minus 3. Then it says here to multiply a by itself, so it's x squared, plus the product of a times b, so 3 times x, which is 3x, and then b by itself, which is 3 squared, which is 9. And this is how you factor out this difference of cubes. The next one is also a sum and difference of cubes, because 64 is a perfect cube, and so is 125. So I'm going to recognize that this is equal to 4x cubed plus 5 cubed. 5 times 5 times 5 is 5 cubed. So here's my a, and here's my b. Whatever I see a formula, an a and a b in this formula, I'm going to substitute 4x and 5 for each of them accordingly. So here we have a, I'll do it down here. So we have a, and then we have a squared. Pay attention to this part. A squared tells me to multiply a by itself. What is 4x times 4x? 16x squared. Then minus ab, minus a times b. So minus 4x times 5 makes 20x. And then plus, remember that the last one is always positive, 5 squared. B squared means 5 squared, so it's 25. Okay, so this is the end of this video. I'm showing you 4 different ways or 4 different techniques on how to factor. When I show you the second part, where we go over about 4 more of those techniques. Please keep practicing. Thank you.